The basic purpose of any amplifier is to take a relatively small input signal and make it larger, typically by increasing the signal voltage. While there are many different kinds of amplifiers, there are three standard configurations for bipolar junction transistors, or BJTs. These are the common base amplifier, the common collector amplifier, and the common emitter amplifier. Transistor amplifiers are common throughout all kinds of electronics, so common that many applications simply could not exist without them. The common collector amplifier, also known as an emitter follower, is one of the three basic single-stage bipolar junction transistor, or BJT amplifier topologies. This configuration is typically used as a voltage buffer. In this configuration, the base is used as the input, the emitter is the output, and the collector is common to both, hence the name. This circuit's impedance particularities make it ideal for use as a voltage buffer. As a voltage buffer, this circuit provides current gain instead of voltage gain. A small change to the input current results in a large change in output current. This configuration is often used in combination with a Zener diode to create a voltage regulator. The common base amplifier is another of the three basic single-stage BJT amplifier topologies. This configuration is typically used as a current buffer or a voltage amplifier. This amplifier uses the emitter terminal as the input and the collector terminal as the output. The base is connected to ground, or common. This style of amplifier is occasionally used as a microphone preamp due to its unusually low input impedance, although it is more popular in high-frequency amplifiers in the VHF and UHF ranges, where its isolation between input and output help to prevent feedback and lead to higher stability. The common emitter amplifier is the last of the three basic single-stage BJT transistor topologies. This configuration is typically used as a voltage amplifier, and this is the type of amplifier you will build in the lab. This type of amplifier uses the base terminal as the input and the collector as the output. The emitter is common to both, either tied to a ground reference or a power supply rail. Common uses for these types of amplifiers are in radio frequency circuits and low noise amplifiers. Each of the three types of single-stage BJT amplifiers have different circuits that they are best suited for. Very often, one type of amplifier is used in conjunction with another, depending on the needs of the circuit. MOSFET is an acronym for metal oxide semiconductor field effect transistor. A MOSFET is a type of transistor used primarily for amplifying or switching signals. MOSFETs today perform pretty much the same function as bipolar junction transistors, except BJTs are current-controlled devices and MOSFETs are voltage-controlled. The most typical application for a MOSFET is a voltage-controlled switch. A MOSFET can be thought of as a kind of variable resistor, where the gate source voltage difference controls the drain source resistance. Where there is no voltage difference between the gate source, the drain source resistance is very high and little to no current flows. When the gate source voltage difference increases, the drain source resistance is reduced and current will flow. MOSFET technology represents some important improvements over bipolar junction transistors. Power MOSFETs are not subject to thermal runaway and other failure modes common to BJTs. However, they are sensitive to gate oxide damage before and during installation. Anti-static handling precautions should be used when dealing with MOSFETs. Another advantage of the MOSFET transistor over a regular transistor is that the MOSFET requires less than 1 milliamp of current to turn on, yet is able to deliver a much higher current to a load of 10 to 50 amps or more. The MOSFET is now the most common type of transistor in both digital and analog circuits. At one time, the bipolar junction transistor was more common than the MOSFET, but things have changed and MOSFET applications now far outnumber those of BJTs. Microprocessors contain millions of integrated MOSFET transistors on each device. The MOSFET devices provide the switching functions to operate logic gates and the data storage required by the microprocessor. Discrete MOSFET devices are used in power supplies, variable frequency drives, and other power electronics applications where the devices may be required to switch hundreds or even thousands of watts.